Velasco and I will be your teacher for today.
We have learned how to compute for the number of moles and atoms and get the atomic number, as well as how to compute for the molar mass. We can now go ahead to our next lesson. During this pandemic, we are constantly sanitizing and disinfecting our hands using alcohol to keep our hands clean and free from bacteria and viruses, especially the COVID-19. If you check the label of your alcohol, you may find that alcohol can be in different concentration. It may be 70% or 99% alcohol. Even though you might think that the higher concentration is better, experts says that 70% alcohol is very good in disinfecting. It has higher dose of water which makes it slower to dissolve, penetrate the skin, and kills a lot of bacteria and viruses. For example, a 70% isopropyl alcohol is low in toxicity level. It has a mixture of 70% pure alcohol and 30% water. This is an example of percentage composition. In the laboratory, you may be tasked to perform experiments that require you to make solutions or to verify the purity of substances. If you are asked to create a salt solution by combining 10 grams of salt with 90 grams of water to create 100 grams of salt solution, and verify what is the percentage composition, what we're going to use as the formula is part divided by whole times 100%. One part is the salt, which is 10 grams, divided by the whole, which is 100 grams of salt solution, times 100%. The answer is correct. There is 10% salt. Now, let's get the percentage composition of water. 90 grams of water divided by 100 grams of the salt solution times 100% is equals to, very good, 90% water. Now that we understand how to get percentage composition, what if we want to compute for the percentage composition of each element in a compound? The simple equation to solve this is mass of the element divided by mass of the compound times 100% is equals to the mass percent. We will illustrate this concept by using ethanol to verify the percentage composition of each element in this compound. Ethanol is made by fermenting different types of organic compound like sugar, corn, grain. To start, first, let's compute for the atomic mass of each element in the compound. The chemical formula for ethanol is C2H6O. This means that there are 2 moles of carbon, 6 moles of hydrogen, and 1 mole of oxygen. Next is to determine the atomic mass of each element that can be found in the periodic table. The atomic mass of carbon is 12.01 gram per mole. For hydrogen, it is 1.01 gram per mole. And for oxygen, it is 16 grams per mole. Next, let's multiply the number of moles with its atomic mass. For carbon, 2 multiplied by 12.01 grams per mole is 24.02 grams per mole. For hydrogen, 6 multiplied by 1.01 gram per mole is 6.048 grams per mole. And for oxygen, 1 multiplied by 16 grams per mole is 16 grams per mole. Now, let's get the molar mass by adding them up. 24.02 plus 6.048 plus 16 is equals to 46.07 grams per mole. Now that we have obtained the molar mass, we can now compute for the mass percent. Mass percent, sometimes called as weight percent, the formula that we're going to use is the atomic mass of the element divided by the molar mass of the compound times 100% to verify the mass percent. Here's the equation. Mass of carbon in 1 mole of ethanol divided by mass of 1 mole of ethanol times 100% to get the mass percent of carbon. 24.02 grams divided by 46.07 grams times 100% is equals to 52.14%. We're going to use the same concept to get the mass percent of hydrogen. 6.048 grams divided by 46.07 grams times 100% is equals to 13.13%. Same goes with oxygen. 16 grams divided by 46.07 grams times 100% is equals to 34.73%. Now, it's your turn to solve these problems. Calculate the mass percent of each element in a compound. Number 1. Methane, CH4. Carbon has an atomic mass of 12.01 grams per mole and hydrogen has an atomic mass of 1.008 grams per mole. Number 2. Sodium nitrate or NaNO3. Sodium has an atomic mass of 23.0 grams per mole, nitrogen has 14 grams per mole, and oxygen has 16 grams per mole. Today we will learn about molar mass and percentage composition. These things are important to learn and understand because almost everything around us in the kitchen, household supplies, chemicals, or products that we put in our body are all composed of different chemicals. And we have an obligation and responsibility to check the composition or elements in these products. That's all for today. See you on the next lesson. Goodbye!